I pull the brushes out of these non-running motors, let me show you why these need replaced. This brush has been run down to the point where it was no longer contacting the armature. You can see from the burn marks on it, there was an actual gap between this and the armature, and it was arcing across that gap, which severely wears the armature. Anytime you have a brush that's been worn down completely, that motor will need to be replaced. There's no point in putting new brushes in because they will arc very heavily and it'll go through them in about 50 hours, and you also run the risk of starting a fire due to the excessive sparking. To change these motors, first we're going to remove this whole outer shroud. There's 3 screws down either side. And an additional 2 screws at either end. The ones at this end are longer, and there are spacers underneath here, so make sure you don't lose those. Make sure all your wires are disconnected from the motors, and this will lift right off. Now we can remove the foam. We're going to be replacing these 3 motors. Anytime you replace a lower motor, you're still going to have to remove the upper motor that's attached with it, because the hose that connects between the two will prevent you from removing that motor. Begin by removing the hose clamps and the hoses from the output. Then you're also going to need to loosen up the hose clamps on the elbow that connects the 2 motors. Now we can tip the machine on its side and unbolt the motors. The upper motor should lift right off. Just going to be stuck on the rubber connector a little bit. Your lower motor may be stuck in the plate a little more firmly because it is a tight fit to get a good seal. Now we will need to remove this rubber hose and put it on the new motor. Typically, if they're stuck on, you can use a screwdriver, pry it loose and break that seal. The only difference between an upper motor and a lower motor is this inlet port is notched a little on the lower motor. That's so that the dust bag doesn't pull up tight against this and only draw air through one portion. We want to make sure that the air can flow through it sideways. That way the entire dust bag surface will be used and not just that one little section. There are 4 spacers here. We want to make sure those stay in place, because without them, that rubber will be tight against and put sideways pressure on this motor. Before we put this motor on, we want to put the boot back on this new motor. You don't want to tighten the clamp yet, because we need to make sure this will line up with the upper motor. easiest to set that down with your plate so you can reach underneath to get your bolts started. Otherwise, those washers may fall out. Now for our upper motor, we have these long spacers. We need to make sure that those go back in. Put your bolt in from the bottom. Don't tighten any of them down until you have all three of these bolts started. Now that that one's bolted in, we can tighten the bolts on the lower motor as well. And then we can tighten our clamps back up. Those two motors are done. Now we have this last one, and then we can put the cover back on. If you have foam, make sure you put that on first. If you've got one of the newer models, you'll have a tin plate that goes in from the top. We want to make sure this seals around the motors, but we don't want it low enough to cut off the air. These motors need air circulation through the motor. So if we put this plate foam all the way down against that motor, it will cut off the air circulation and the motor will overheat. Make sure all your wires are on the inside. We don't want those to get pinched. Your power panel goes at the same end as your inlet tube. The long bolts and spacers go at this end. You want to get those in first. Get all the rest of your bolts started before you tighten anything down. Now we want to hook all our motors back up. It doesn't matter which wire plugs into which connector. All four of these go to the same place. Now we'll test run it. Because the motors are hooked up in pairs, it's difficult to tell if one of the motors is not running because it'll still be spun over by the other one blowing or pulling through it. So the best way to tell if all your motors are running is check your amp meter here. If you've got a newer system, it's going to be a combined amp and hour meter instead of two separate ones. But what we're looking for is somewhere between 28 and 32 amps. It all depends on the voltage. We may see a little lower here because we only have 210 volts, but if you're on 230 to 240 volts, you should see it somewhere between 28 and 32 amps. As motors go out, you'll see that drop by a quarter. So if you have two motors out, you'll only be drawing about 14 amps. In this case, it's drawing 17 amps. Low current draw may simply be due to the fact that this has sucked itself down to the motor plate, and what happens is the motors are not moving any air, and so they will draw less power. If I move this over so that it can get some airflow underneath, let's see what we get. And now it's up at 25 amps, which is where I would expect to see it with 210 volt input. So this system is all set. We just have to put the top cover back on and it's good to go.